Hello students, next we will look into the next topic, which is mesh analysis with dependent source. Mesh analysis with dependent source. Here I have said dependent source I have put in a different color because this is mesh analysis in which the source is having at least one dependent source. Now if you would remember very clearly, I had already, told that there are two kinds of sources. One is a independent source. Let's say the voltage source is like this. The dependent source is basically a rhombus, like this, the diamond shape or the rhombus shape. So what you have to be careful is whenever you are having a shape like this, it means we are talking about the dependent source. So here we are having two dependent sources. One is here and another is here. We also have independent sources, which are these two. But it does not matter because as soon as we have one dependent source, we have to be careful. Now, generally, people think that it's going to be a very tough problem. It's not at all tough. It's not at all tough because you have to only take care of two things here. The first thing you have to take care is if this is a control source, then is it a voltage source or a current source? That is the only two questions that you have to ask. Is this a voltage source or a current source? Now, as you can see, the polarity is already given. So, this is a voltage source. Don't go by this. Don't go by what is the value written here. Because that is only going to give you the value. It's not going to give you whether it is a voltage source or a current source. The only thing that is going to say if this is a current source or a voltage source is this polarity. So here what we are having is a voltage source. Similarly here also we are having what is called as a voltage source. So it's actually basically a simple mesh analysis circuit with four voltage sources, which I am marking here, out of which these two are dependent source and the other two are independent source. So let me write the KVL equation because that is what is going to give me the answer. Now what they are asking here is find out the value of IA and IB. So here this is written as IA. See, I can basically write this current as I1, but I will write it as IA because that is the same current that is flowing here, isn't it? Similarly, I will write this current as IB because that is the same current that is flowing in this particular branch. So IB is going to be same. If IB was here, then I would have written something else. Okay. If IB would have been here, I would have written something else. But anyway, so we have a straightforward mesh equation. So I will do what we normally do. KVL at mesh 1. So going by the polarity, this is plus minus, here it will be plus minus, here it will be plus minus, the rest of the polarities are given. I will go by the negative value, I mean the back of the bogie. So this is going to be minus 5, the first one, minus 5, here back of the bogie is going to be plus 5 IA. Similarly here it is going to be plus 10 IB. See, what is to be noticed here is that all you need to do, I told you about two things. The first thing is that you take care of the polarity. The second thing is that you have to take care is of what is the value given. Straight away write that value because that is a voltage value because this is a voltage source. So this is going to be plus 10 IB. Let me correct this one. This is 5 IA. So I should write this as 5 IA. Okay. So 5 IA, 10 IB. Now next is this one. So here I am having plus 10 IA minus IB. Then I am having plus 5IA. See, look at this circuit. Look at this particular equation. All you are having is equations which are either belonging to IA or belonging to IB. There is no other variable written in this. So this is a simple equation which we can rewrite by combining all the IA components. So here we are having 5IA, 10IA, 5IA combined, and then we are having 10IB and minus 10IB, which we can again combine. So let me write it. So minus 5 will go the other side, all 5 for the first one, then we are having plus 10 IA plus 5 IA, the whole combined IA. Then I am having IB, so I will have 10 IB minus 10 IB is equal to this minus 5. If I take the other side, I will get plus 5. So therefore I can simply write 20 IA plus 0 IB is equal to 5. Now from here I can actually find out IA directly. Therefore IA is going to be equal to 5 by 20, which is going to be 1 by 4. Okay, so anyway, there is no need to use calculator. I have directly found out IA here. Next we will go for the second mesh. So KVL at mesh 2, the second mesh. Okay, KVL at mesh 2. So KVL at mesh 2, again I will have to write the polarity. So since IB flows like this, I will write this as plus minus plus minus. This is already plus. So now I can start from, let's say, for a change I will go from the front of the bogie. So now I am going to have 5IA, so plus 5IA minus 10IB minus IA, IB minus IA minus 5IB minus 10 is equal to 0. From where I can actually combine 5 plus 10 IA and IB, I can combine it as minus 10 and minus 5. So that will give me IB, and the minus 10 I can take the other side to be plus 10. Therefore the second equation that I am going to have is 15IA minus 15IB, okay, is equal to 10. IB I already know, IA I already know from here. So what I am going to do is, therefore 15 times IA is 1 by 4 minus 15 times IB is going to be equal to 10. From where, if I take this one the other side, I will get, therefore IB is going to be equal to minus 0.416 amperes, and that is going to be the solution. I suppose you can do this on your own. This part from here to here, you can do it on your own. So that is how we have found out IA and IB for the case when we are having a dependent source. So what do you learn from this? What we learn is that it does not matter whatever is the case of dependent source. All you have to look into is two things. One is, what kind of source is this? Is this a voltage source or a current source? If it is a current source, then we will have to go for super mesh or simple mesh. But if it's a voltage source, as it's the case here, then it becomes very simple. And always remember, this particular value you have to substitute as such. Don't look anything else. Don't get confused. Directly write that value as voltage if it's a voltage source. If it's a current source, then write that as the current. Thank you.